Welcome to the product tour for Aerospace Pro's 6 Degree of Freedom Simulink Flight Simulation template. Each template includes an optional MATLAB initialization script. This script sets up structures in the MATLAB workspace for each of the simulation's top-level models. It also establishes structures for the simulation's initial conditions and basic controls, such as setting the solver step size. Let's create a Simulink model. If you're unfamiliar with Simulink templates, they are essentially stored in a folder on the MATLAB path. When you launch Simulink, these templates appear under My Templates. Simply click on a template, and Simulink will generate a new model. Here is your top-level model view, which includes the equations of motion, simulation output, environment, external systems, and the vehicle model. Opening the equations of motion model reveals two subsystems, one for the state and another for auxiliary parameters. Within the state model, there is a block that sums forces, moments, and momentum, along with the expanded equations of motion. This includes the actual state vector and several other parameters that are easily captured here. The attitude mechanization in this template utilizes quaternions, and a feature is included to monitor the orthogonality of the quaternions. Moving on to the auxiliary block, this section is customizable but already includes several key calculations, such as true airspeed, calibrated airspeed, equivalent airspeed, dynamic pressure, Reynolds number, Mach number, angle of attack, and angle of side slip. It's an ideal place to perform coordinate transformations or extract common parameters, like altitude, from state vectors. The simulation output block is dedicated to charting, post-processing, and storing model outputs. It includes a specialized subsystem for visualization, especially when using tools like Sim3D. Additionally, there is a subsystem designed to stop the simulation based on specific parameters. The environment model encompasses all flight environment models, which are categorized into three types: astronomical, atmospheric, and geodesy. The astronomical model includes features related to time tracking and relevant space effects, such as the sun's position. The atmosphere model consists of properties and winds models. The template provides a 1962 standard atmosphere, which can be easily replaced with a model of your choice if needed. The winds model is largely customizable, and a simple wind generation model is included to simulate constant three-dimensional winds. The geodesy model includes planetary body models applicable to Earth, the Moon, etc. It provides for surface features, body shape, gravity, and magnetism. Currently, only the gravity model is populated. Since these are flat Earth equations of motion, only a single value for gravitational acceleration is required. Note that the equations of motion currently require setting gravity there as well, but this behavior will be removed in a future version of the template. The external systems model encompasses all components not integrated into the vehicle itself. For instance, it can include models for a drone ground control station and data link. Additionally, it can incorporate models for other vehicles to simulate engagements and collisions. Finally, we have the vehicle model. It is divided into system models and physical models, which output forces, moments, and momentum. These include weights, aerodynamics, propulsion, and a category for other forces, moments, and momentum. The flight control system model includes empty placeholder models for the pilot, the operational flight program, and actuation. The pilot model simulates onboard pilot inputs. The operational flight program contains models for automatic flight controls, stability augmentation systems, etc. These models can be developed using Simulink, compiled S functions with actual software, or even connected to actual hardware. The actuation models simulate actuators and linkages for flight control surfaces, high lift devices, braking surfaces, thrust vectoring, etc. The vehicle systems model includes empty placeholder models for avionics, mechanical, and electrical systems. In avionics, you would add models for inertial navigation, air data, missile seekers, and other hardware. The mechanical system could include models for landing gear movement, fuel usage, and transfer. The electrical system would be used for modeling batteries, other forms of power generation, and various types of electrical failure modes. The payload model would contain the models for any internal or external stores, for example, the motion for a camera gimbal. The weights or mass properties model includes a single fixed weight with center of gravity and inertias. The inertia rate is a parameter for the aerospace block set's 6 degrees of freedom equations of motion in a future version of this template. The aerodynamics model is designed to generate both aerodynamic forces and moments. Forces are calculated using axial, side, and normal force coefficients, which you can customize. Moments about the center of gravity are calculated for roll, pitch, and yaw, based on coefficient models you will develop. The inputs for these forces and moments should support most standard approaches to coefficient buildup. We will soon offer an aerodynamics modeling library to simplify this process. Next, the propulsion model is home to models for propulsion forces and moments, as well as momentum from any spinning rotors. It would also house the engine dynamics model if you choose to create one. Finally, we have the other forces, moments, and momentum model. This model is supposed to be the home for anything not weights, aerodynamics, or propulsion. It could include landing gear reactions, as well as physical models for catapults, parachutes, etc. That concludes this product tour. For more information on features and pricing, please visit our website.